Hello Internet, I'm Guy. Recently I was looking at my dial indicator and it occurred to me that it looks a little bit like a clock face. So if you look at the sketch I'm putting up on the screen right now, my thought would be that I could engineer it so that every rotation is 12 hours. So what that requires is a very precise linear motor underneath the bottom pushing this up. And I found one that has the resolution to accomplish this. And of course I'm going to build some electronics to program it to move very, very slowly around like that. I'm also going to put a bezel around the outside here with 12 dots to indicate the time in hours, nearest to the nearest hour. Of course this doesn't reflect hours, it's all in tenths and thousandths. So I think I'll leave the original dial gauge in there, but have these dots on the outside to show the time. It's going to be an interesting process, so stick with me and we'll see how it works out. So let's jump right in. I've got a piece of plumbing pipe here that I'm going to use for the cylindrical part of the base. That's pretty easy. And then I'm going to make the aluminum rings or discs that go on the top and bottom here. So I'm going to mark centers on those and then draw the outline for each one and cut them out. So get the center punch right there so I can be sure to repeat that center, because it's going to be important in the process as I work through this to have a reliable center. These are an extra large pair of compasses here, which I got free as a gift from one of my suppliers. Pretty nice tool. So on my woodworking bandsaw here, which I also obviously use for aluminum and metal work, I'm just going to cut the circle out, top and bottom. And then I'm going to drill a 1/4 inch hole in each of these, starting with a starting drill and then going up to a 1/4 inch drill. The reason for this is I need to chuck it up on the lathe so that I can spin them both up and get them both dialed into the same exact radius. So here's my 1/4 inch hole. And now I've got them both bolted together on a pump rod connector, or a long nut essentially, with a bolt through it, and that goes in the jaws really nicely. And bring in my cutter, and I'm going to start dialing down those shapes, which are obviously a little rough right now, and they're also a little off-center, so this is going to tidy everything up and neaten it up. Here's a close-up of just getting that final cut done. Cleaning up the corners with my lathe file, just take off some corners there and that side too. And now I'm down to one disc, and I'm using some sandpaper to create some beautiful sort of round lines in the metal just to make it look pretty. I'm using a step drill now to open up the hole big enough for the motor to come in on the top disc. Notice I have all that blue tape there to protect the finish that I'd already made. Step drills are wonderful for so many reasons. Look at that beautiful bevel that it already creates for you. So now I've got it back. I've moved from the drill press over to the mill, and I'm using the step drill to center the metal before I clamp it down, using MDF, so again I don't scar the finish on the metal. Get those both clamped down firmly. So double checking that I've got my concentricity, and there you are. I mean, that's what's so wonderful about these step drills. You can recenter easily. So now I'm using my touch DRO to identify the locations of the 4 bolts that will secure the motor that will be in the bottom below this, with part of it sticking up above. So I've figured out the radius and positions of the bolt pattern and just entered it in my DRO as one does. These are M3.5 bolts. There you are. You see the bolt holes, and it'll go in like that, but from the other side, essentially. So this is the bottom base part, and I recentered on the 1/4 inch drill in this case. And so now I'm just going to drill some holes so that I can screw it on to the piece of plastic pipe that I showed earlier. I'm going to be painting that eventually. And countersinking the hole. You notice some wiggle there. That's because my keyless chuck, if you don't put the drill in far enough, it doesn't center well, and I didn't notice that until I just finished that. So I've got it better in the next few cuts here. So now I've got a piece of brass here that I'm going to use to make a little seat on the top of the motor shaft where the bottom edge of the dial indicator will rest on it. And I just wanted to make it look pretty and screw on to the threads at the bottom end of the dial indicator. So here I am drilling a center drill and then a tap drill, and there we go. Tapping it by hand here, and then once it's already tapped all the way in, I can just drive the tap out with the motor and getting it onto the motor to check fit, and it fits just fine. Now I'm using my brass protectors on the 3-jaw chuck, and then I'm going to bring in my bearing bump tool, something I made a while ago, and I'll put a link to the video below. That helps center things in situations like this. So reducing the diameter a little bit, reducing the length next. Brass is such a delight to work with. Kind of round off the edge with my lathe file, and then a little bit of Scotch-Brite to just shine it up a bit. And double check that it goes on the motor. There we go. That looks a lot prettier than the original shaft on the motor. So I'm going to drill and tap holes in the plumbing pipe, which is the cylindrical base for the whole clock. Again, PVC is a very amenable, or is it ABS? I'm not sure. Very amenable material. Now that's the circuit board there. I'm going to talk about that a little bit later. But I've drilled a bunch of extra holes in the base now to mount the circuit board. And there's another larger hole that I'll talk about in a moment. These are 440 tap flathead screws. Now this is a button switch right here that's going to go in right here. And the purpose of that is so you can set the time by pushing it forward or back 1 hour for daylight savings time. There's actually no need to set the minutes because the real-time clock in the electronics that I've designed will remember the time, because that little thing flopping around there in the little black container holds a CR2032 coin battery. So it'll keep the clock running whether it's unplugged or not and maintain perfect time all the time. So now I'm going to work on this post that holds up the dial gauge, and this is actually a scrap of hardened steel I found in a printer that I've saved. You never know when you need stuff like that. It's a beautiful piece of metal, all nice and shiny, cut pretty well. So I'm just cleaning it up, tidying up the end, facing it off as one does. Do a little test fit. This was, I believe, an 832 cap head screw. So the motor will go in like that, and then the dial gauge will be supported like this with another part that I need to make. So there's the next part I'm going to make, the bracket that connects these two. So I've got a little scrap of metal here, and I've marked off my 2 hole locations. The distance between them is important, but the rest of it is less important. It's more aesthetical. Aesthetical, is that a word? So I'm going to clean up that surface. Get both sides done. And then I pre-drilled the center drills for these 2 holes. I didn't show that in the video. The one hole for the post is 9 millimeters, which is what I'm drilling here. The other hole is 3/8, which apparently all dial indicators base mount is 3/8 inch, imperial measurement.
Okay, so I've messed up. I don't know whether you can see this, but first of all, the holes are not centered here. While this hole is a good size to fit onto here, and that's a really nice fit, in order to get this hole to fit, I started with a 3/8 hole, which is what this dimension is, and had to bore it out because it was too tight. I've got a different remedy for that next time I make this, but the other thing I was planning to do was to round these ends over on my rotary table. So in order to mount it to a rotary table, or my rotary table anyway, I drill 1/4 inch holes, and then I can bolt it right into the center of the table, similar to this, and then rotate it like that. So I should not have drilled these holes out to full size first. So I'm going to go back in and do this over again, drill 1/4 inch holes, round the ends over, and get them centered too. So here we go.
So deja vu all over again. I'm just truing up the stock just like I did the first time. And now I'm going to use my centering tool. This is my Fowler electronic centering tool to make sure I get centered and also to find the edge so I can get dimension positions for the two holes. So there's my edge position. Drill the first hole. And the second hole, drill them out. So this is, I believe, my 9mm. Oh no, that's right, of course it's not. It's a 1/4 inch hole for both holes. That's all I need. So now I've used a cap screw to bolt it into a threaded hole that I put into my rotary table. Now I've set a stop on the height of my mill so that it doesn't hit the table, and there's a washer underneath that block that I'm machining here to clear it from the rotary table. So this looks like it's working out just fine. I'm keeping a little tension on the left-hand tensioning knob, which is the locking knob for the rotary table, because it tended to wobble a little bit if I didn't. So I'm going to go back and forth. I've got a slight tension, as you can see, on that knob now. I'm just leaving it there. And that came out really nicely. So I'm just going to flip it around and do the other side. You see I have two washers under there. One under the bolt and one at the other end to keep it balanced. So I'm going to put that other washer back under there and then torque it down. This rotary table did not come with that threaded hole, but it turned out that the hole size that came with the rotary table was the perfect tap drill size for 1/4x20. So here we are. That looks pretty good. I'm just going to take it over to the belt sander, there you go, and get it all just cleaned up. So now I'm going to center back on that hole on the milling machine and drill this one out to the 9mm again for the post. That's my 440 squirt bottle on the left, as you can see. And then this is the 3/8. I'm going directly only to a 3/8 inch drill at this point because I think that's going to make a better fit. Last time I tried a smaller drill and then going up to 3/8, and that was too tight. So now I'm going to deburr with my cordless drill. I find this a nice, quick, and easy way to do deburring on holes. So let's see how it fits now. This is the 9mm going back on the top. And that's even more snug than last time, which is great. And also, this is really quite snug. So that works out really well. The only thing I have to do now is put a couple of set screws in the sides of the thing here. So centering up on each edge again to get center line. And drilling a tap hole for, I think, a 6 or an 832, I don't remember. That one went in pretty nicely, but you notice it kind of sprung when I removed the drill. And in this case, the drill is kind of wandering a little bit, and I thought, I really should be using a centering drill here. So I tried to ease it in again, and that's not working. So centering drill should be able to work its way in and recenter that hole. Yeah, that's going to work fine. So back to the tap drill, and that'll just drop in that centered hole. So before I even started building the clock, I developed the electronics, and as you can see here, there's a red circuit that is the stepper motor driver circuit. The bottom left black chip is the microcontroller that I programmed, and the top left black chip there is the real-time clock chip. That little LED on the front edge that says RTC 1 Hz blinks 1 time per second to let me know that it's working properly. Okay, so now I have some Delrin chucked up in the lathe, and I'm just cutting off some pieces to make into feet for the bottom of the whole device, because the button sticks out at the bottom, the little red button you see in the back of the picture here. So I needed to have some feet high enough to clear that button sticking out, and the button, as I mentioned earlier, is for setting time. If you press it briefly, it'll move the hour forward by 1, and press it for over 1.5 seconds, and that'll move the clock back by 1 hour. That'll just accomplish the changing from daylight savings time plus and minus 1 hour. The rest of the time, the real-time clock will be 100% accurate to the minutes. So now I've drawn out these 2 circles for the faceplate for the clock hand positions, if you will. and center drilling this, which is going to be important. Now I've recentered it on my milling machine. I'm going to clamp that down very securely, and I'm going to bore out that hole. The order of operations for this kept me up at night for a while until I figured it out, and this is the logical way to go. I'm using my fly cutter here, but it doesn't go deep enough. As you'll see shortly, kind of running out of cutter head here. And I keep trying and trying and go, no, it's just galling up the plastic. So I've got to come up with plan B. So I went with a really big Forstner bit, one of the biggest ones I have, but that is actually just too big. It's not really chewing into the wood very well. I mean, it sort of is, but it's stalling the machine. So I'm kind of struggling with that. So, okay, drop back a size. That should be a little easier. I wish I'd thought this through a bit more at the beginning, but hey, I'm getting there, right? Yes, and of course the shop vac helps a lot. This stuff gets everywhere. So I've gotten through that, and now I'm going up another step. Forstner bits are great. I have a set of probably 20 of these in every size, fractional size you can get. Cleaning up a little bit, and then I'm going to go up one more size, and it's going to be really close. So then I can come back in with the fly cutter and clean that out. All right, here we go. Now I had set the fly cutter to slightly smaller than the size, intending to come in with my boring bar, and it turns out actually that I hit the size perfectly. See that weird wobbling going on? That's a vibration that's happening between the camera and the milling machine, so ignore that. I'm just checking the dial gauge here, and guess what? That is just a snug fit. Just a tiny bit of sanding and reaming gets that to fit perfectly. So now I've got a tap drill for a 440 bolt, and I've got my touch DRO circle set up for the 12 hand positions on this faceplate here. I'm going to drill these holes and then of course tap them for 440 so I can put some bolts in there. So I'm just going around here drilling out all these clock positions. Something oddly satisfying about doing a set of circle of holes using the DRO. So now I'm going to cut the acrylic out. This is, by the way, cast black acrylic. If you're ever working with acrylic and want to machine or cut it, do not buy extruded. It will get warm, and the moment it gets warm, it'll gum up. You must buy cast acrylic. So you notice the chips were very sort of dry and so forth on that, and if it had got warm on the blade before, it would have been really messy. So now, fortunately, it fits on my chuck, and so I can now get this concentric with my cutter on the left there. It wasn't perfectly concentric on the outside because something shifted, I think, on the middle when I did some of the interior work. So I'm going to clean up the edge with a lathe file, just take the edge off a little bit. So now I'm going to use some medium grit Scotch-Brite, and in my first pass here I forgot that one of the best ways to do this kind of finish on plastic or aluminum is with Scotch-Brite but with some WD-40 on it. So I'm not showing that right here, but I did go back in afterwards, and that just makes a nicer finish. I thought that would be a useful thing to share for folks that want to have that brushed aluminum type finish, or brushed plastic in this case. Just soak the Scotch-Brite in a little WD-40. I should have taken some footage of that, but I forgot to. You'll get the idea, though. It just looks nicer, shinier, better finish. So right there it looks kind of matte and a little bit sort of powdery looking. So here's my box of stainless steel Phillips head, pan head, 440 bolts, and they just fit in perfectly because they're 1/4 inch bolts, and so is the plastic is 1/4 inch. So let's see how that's going to look. It should just kind of snap right on there, and so it does. So that's my clock face. I'm pretty pleased with that. It just looks like it belongs there, doesn't it? I had previously spray painted the piece of pipe with black hammer tone. It has a little bit of a silver metallic hammer tone in this particular paint, which I like. So I'm going to use my favorite adhesive, which is Goop, and I'm just going to glue that onto the bottom of the top disc there, which you see has the motor sticking out of it right now. I figure I can glue that on because it doesn't need to be separated or removed. I'm going to feed that wire through and try and plop it on there as centered as best I can. An interesting side note about this cute little motor, it is a precision linear stepper motor, so it can move in increments of 0.000125 inch. So to do 12 hours it needs 12,800 steps, one step every 3.375 seconds. I've been mentoring a young guy named Earl Ranta, who I've been teaching him all of my skills, woodworking, metalworking, machining, and code development. So he and I worked together on the firmware to develop this code that creates the timing to make this clock work, and also the time set features and all the other features. He's a bit of a math whiz, and he really helped me out on this. So here's the finished clock. I'm just going to plug it in, and what it'll do is it'll wind back, calibrate to noon position, and then count the hours to the current time, pausing at each hour. And then it'll also run there, the minutes after the hour. So it is about 7:20. So if I push this button briefly, it'll move forwards by 1 hour. And then if I press and hold the button and release it, it'll go back by an hour. So it'll go back to the original time there.
So there you have it, a dial indicator clock. Who knew? If you're interested in maybe making your own, I'm considering offering a kit that would include the electronics and the linear motor, this little part right in here. So let me know in the comments if that appeals to you. I figure a lot of you guys are home shop machinists and you might be looking for fun projects to do. Dial indicators are affordable. You can buy your own and build your own mechanism. So if I see enough interest, I will put together a small production run of kits and we'll see how that goes. I do have experience producing kits and I can provide very good detailed instructions and so forth, so I'm no newbie to that kind of thing. So I hope you enjoyed the video. Please remember to give me a thumbs up or subscribe if you haven't already. And you can also support me on Patreon with the link in the description below. Thanks for watching. See you another time.